last video we looked at this thing they call permutation, and we saw that if you have n items available and you choose r out of the n, whatever that is, the number of ways to arrange them where the order matters, which we call permutation. This is how you write it, NPR. So it's superscript n, normal p, and subscript r equals. It's n factorial over n minus r factorial. Now, there's another formula, same book that I told you before I was looking at. This is page 672 of the core maths for A level by L. Bostock and S. Chandler, second edition. It gives a formula for the combination. What it says is that you have R objects. If you have R objects chosen from N, so you have N available, and you choose R. The book gives these as lowercase, alright, even though I'm writing my R as uppercase. You choose R, then the number of combinations is written NCR. And the formula is this. It's n factorial over n minus r factorial times r factorial. We're going to see if this works with a few examples. If it works for these examples. Now, here, let us pick 4 out of 4 items. We're going to look at the permutation and then the combinations. How many ways can you arrange these? Well, according to the permutation formula, you should get 4 factorial, which is n factorial, number available 4, divided by, and you are looking at 4 minus 4 factorial, 4 minus 4 factorial, which would be 0 factorial. 0 factorial is 1. So it's 4 factorial. You're choosing 4 out of 4. So that's 4 factorial, which is 4 3 is 12, 12 2 is 24. It would be 24 divided by 1. So the answer would be 24 arrangements. We've seen in a previous video where we arranged everything and we saw that there were 24 of them. But remember, we said that all 24 arrangements is just one combination if you consider that the order doesn't matter. Now, here, what we have is saying that it is n factorial, 4 factorial, that's the number available, divided by n minus r factorial, so it's 4 available, minus you choose 4 factorial, multiplied by r factorial, which is 4 factorial. So here 4 factorial, which is 4 by 3 by 2 by 1 divided by 4 minus 4 factorial is 0 factorial times 4 factorial, which is 4 by 3 by 2 by 1. We see that 0 factorial is really 1. So this amounts to 1. 4 by 3 by 2 by 1 cancels 4 by 3 by 2 by 1. So the answer would be 1. So remember, we had said when we worked it out before in the former video, and we had, for example, A, B, C, D, and we have A, B, D, C, and we had B, D, C, A, and so on. There were 24 of them. That's 24. That's 24 permutation, but one combination. Let's try something else with this thing. Suppose I pick 3 out of the 4 available. 3 out of 4. Remember what happened before? Let me erase these things to make space. And by the way, let me put a box around this formula, another important formula. This up here was just a piece of working. Alright. Now, here, A, B, C, D. We choose 3 out of the 4. What happened before? We said that according to the formula, 4P3, 4 available, we choose 3 to arrange, would be 4 factorial divided by 4 minus 3 factorial. And there were 24 of them in a former video, in a previous video under this topic, right? If you didn't watch it, I recommend you go back and watch that video and then come back here. So the answer for this was 24. But what would it be for the combination? You have 4, choose with combination 3, it would be n factorial, which would be 4 factorial divided by 4 minus 3 factorial, that's n minus r factorial, times r factorial, which is 3 factorial. So it would be 4 factorial over 3 factorial. So in this case, it's 4 by 3 by 2 by 1 over 3 by 2 by 1. So you would get 4. 4 of them. You would have 4 combinations. Now, since you have 4 combinations here, let's just do a quick look back at what we got when we arranged these. We had, it was 24 of them, 3 out of 4, A, B, C, A, B, D, alright, A, C, D, A, C, B, that's A, B, A, C, A, D, C, A, D, B. Alright, so we finished all when we started with A, start with B. We have B, A, C, B, A, D, B, C, D, B, C, A, B, D, A, B, D, C. Alright, so that's 12 so far. Then we have starting with C, C, A, B, C, A, D, C, B, A, C, B, D, C, D, A, C, D, B. Alright, one more set. We start with D, D, A, B, D, B, A, D, C, A, D, C, B, D, B, A, D, B, C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 permutations. Now the number of combinations is what? How many combinations do we have? Alright. We're looking for those in which you have the same letters. It doesn't matter the arrangement. Remember, the combination where we have the arrangements where we have the letters and the order doesn't matter. We're looking at one combination. So ABC, ACB, BCA, those are all the same. So let's see. ABC. I'm looking for A, B, and C again. Whatever the whatever the arrangement. So we have A, B, A, C, same thing. Alright. C, B, A, same thing. Right. Now let's look for another one. ACB is the same. Alright. We look for another one. BCA, CBA. Alright, so that's 1, 2, 3, 4, 5, 6 of them. Okay. Now, we have found these as one combination of A, B, and C. Let's look for a combination of, what would it be now? BCD. BCD now. Let's just erase. This was ACB, CAB. In other words, those that don't have any D in them, that's what we looked at. Just A, B, and C. Now, let us look for those that have A. Let me see now. A, C, and D. No B. No B's at all. Alright. ACD. Good. ACD. Good. CAD. Alright. No B's. No B's at all in them. We have CDA. So we have 1, 2, 3, 4, 5. Should not have a B in it. No B. No B at all. Okay. So we have these as well. So we looked and found those without any D. Then we looked for those with no B. Let us look for BCD. In other words, no A. No A at all. Alright? This doesn't have an A. 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 Alright. So, let's get rid of those with no A's. So these did not have any A's. What about those without C? No C. Alright, no C here. No C's here. No C's here. None. Here, here, here. No C. C. Oh, I didn't delete this one. CBD. CBD is the same as CDB, is the same as DCB. Alright, so my mistake, I didn't delete this. Alright, so we found 4 sets of numbers. Those with no A, then no B, then no C, then no D. 4 sets of numbers in which we don't care about the order. So 4C3 is indeed 4. We have seen here that if you have 4 items to arrange 3 out of them, you would get 4. Now, what about picking 2 out of the 4? What would be the permutations and the combination? Alright, what the permutation formula says is that you have 4 available and you choose 2. It's permutation. It would be 4 factorial over 4 minus 2 factorial. Alright, let's work it out here. 4 factorial is 4 by 3 by 2 by 1 over 2 factorial, because 4 minus 2 is 2, so it's 2 factorial is 2 by 1. 2 by 1 cancel 2 by 1, so it's 4 3 is 12. Now, that would be 12. So the answer here would be 12. Let's write that down here. In other words, if you pick 2 out of the 4, you could have A first, AB, or AC, or AD, or you could say B first. So you have BA, BC, BD, or you could say C first. So you have CA, CB, CD, or you could have D first. So you have DA, DB, DC, nothing else is there. So you have 3, 4, 12 of them. Alright. So it's the permutation is 12 permutations. Let us see what would happen here if we look at the combination 4C2. You arrange 2 from 4. This will be 4 factorial over 4 minus 2 factorial, which is equal to 4 factorial is 4 by 3 by 2 by 1 divided by 4 minus 2 is 2. So 2 factorial is 2 by 1 times this 2 factorial is 2 by 1. So 2 by 1 cancel 2 by 1. 2 into 2, 1, 2 into 4, 2, 2, 3, 6. So this is saying there will be 6 combinations. Let's see. 6 combination. Alright. AB and BA is the same. CA and AC. So we have CA and AC. Okay. So this is 1. This is 2. Alright. CB and BC are the same. So this is the third one, 3. AD and DA are the same. So this is 4. BD and DB are the same. So this is the 5th. CD and DC are the same. So this is the 6th. So it is 6. It does work. So when you choose 2 from 4, number of permutations you have is 12. That means you can arrange them 12 ways where the order matters, or you can arrange them 6 ways where the order doesn't matter. CD and DC are the same. Alright? Now, suppose you choose 1 out of the 4. Let's erase these things here and choose 1 out of the 4 available items here and see what will happen. So you choose 1 out of 4. Let's erase some of what we have here and make the necessary adjustments. Now we're going to choose 1 letter out of 4 available letters and see how we can arrange them. But before that, let's use the formulas. 4p1 would be 4 factorial over 1 factorial. No, over 4 minus 1 factorial, I mean. Over 4 minus 1 factorial. Let's work it out here. 4 factorial over 4 minus 1 factorial is 3 factorial. 4 factorial is 4 by 3 by 2 by 1. 3 factorial is 3 by 2 by 1. When you cancel down, you get 4. So the answer for this will be 4. What about 4C1? In this case, this would be 4 factorial divided by, so it's n factorial. N is 4, the number available is 4. And the number that you choose to arrange is 1. So R is 1. So n factorial, which is 4 factorial, over n minus R, which is 4 minus 1 factorial, times R factorial, where R factorial would be 1 factorial. So 4 factorial. Let's work it out here. 4 by 3 by 2 by 1 divided by 4 minus 1 is 3. 3 by 2 by 1 times 1 factorial is just 1. So the answer you get for this is the same 4. Now, let's list them out one by one. Remember, what we did here was to say you have 4 available, n would be 4. Permutation, you arrange them where the order matters, and you choose 2. You choose r from the 4. So it's npr, which is 4p1, is 4 factorial divided by 4 minus 1 factorial. Right? The number available divided by the number available minus the number you choose, that factorial, and we get 4. For the combination, remember, it's NCR. That means the number available, C, the number you choose out of that, is equal to, and you're going to arrange them where the order doesn't matter how many ways you arrange them. It's n factorial divided by n minus r factorial, where n is 4 and r is 1. So in this case, 4 factorial over 4 minus 1 factorial gives us 4. So there are 4 permutations at the same time, 4 combinations as well. Let's see what those things are. You choose one letter out of the 4. You can choose A first. Good. The other choice you could make is B or C or D. These are 4 arrangements where the order matters. But there's also 4 arrangements where the order doesn't matter, because there's only 1 letter there. You don't have 2 letters or more putting in any order. So the number of ways you can arrange these is 4, whether the order matters or not in this case. So those are the factorials, the permutations, and the combinations. I'll see you in the next video.